In the area of science and gigantic mysteries, the subject of what existed previously to the gigantic explosion has sparked mixed conversations and fascinated characters for quite some time. This enormous question doesn't just test how we could decipher the universe, it challenges the genuine furthest limits of human knowledge. Imagine standing at the edge of existence, examining the colossal shadow and pondering what lay there, what existed before our universe was imagined. The event of the Big Bang marked the beginning of time, space, and all that we know. In any case, were you there a moment earlier? In the past, this might have been a state of nothingness, a state of calm before the cosmic gathering started. And if this is accurate, maybe there was something much more alarming that existed before the beginning of time. As we jump deeper into this question, science takes us on a journey past the universe's beginning point, into thoughts that challenge our consciousness. Physicist Brian Cox, known for his examination of the wonders of the universe, suggests that something surprising might have existed before the massive explosion. He directs us to reconsider our thoughts on reality and existence. In this investigation, we dissect the science, the speculation, and the dazzling insider secrets that might make sense of what existed preceding all that. We'll explore thoughts like self-importance and growth, quantum alters, dark energy, and multiverse as well. The responses we've provided may just paralyze you, but they might also open new understandings of our position. Prepare to plunge into the depths of the universe, into a world beyond imagination and science, where the obscure still wins around the scientist who left in the shadows, flawed and sometimes even upset. We ought to investigate the period preceding the Big Bang and why these theories challenge all that we thought we knew. To appreciate what may have existed before the Big Bang, we must first painstakingly analyze what the Big Bang truly was. The Big Bang, as scientists define it, refers to the moment when the universe became extremely dense and hot, rapidly expanding to cause the development of all matter, energy, and boundless forces. When we look toward the night sky, it reveals evidence of this hot beginning, with the expansion of galaxies this way and that from an early starting point. However, why did this happen? Furthermore, was there a period prior to this blazingly fast start? As indicated by the theory of enormous expansion, there was indeed a before, and it didn't even come close to being void or peaceful. Vast expansion suggests that before the Big Bang, the universe was in a state that was cold, vacant, and loose, essentially like an immense vacuum. Nonetheless, this vacuum was not entirely empty. It contained a gigantic amount of vitality that fueled the rapid extension of space itself. This extension, called inflation, happened so rapidly that, in essence, it established the groundwork for all that would continue, a portion of the following space extending at unfathomable rates until the extension slowed down, and the energy transformed into matter-like atoms and the forces that we consider to be the Big Bang. But what was the nature of this energy? Why did it suddenly grow the universe, and why did it stop? Specialists believe that this inestimable expansion made patches of the universe, each undergoing its own Big Bang. Think of a fabric that extends indefinitely, with minuscule air pockets forming here and there. Each air pocket represented a universe, including our own. This thought, called the inflationary multiverse, suggests that there could be limitless Big Bangs and an infinite number of universes. Our own is just one of many. This huge, mind-bending reality challenges our understanding of the very universe itself and leaves us with inquiries. Are there any other alternatives to the concept of nothingness before the Big Bang? It's speculative, not real, at any rate as per our current comprehension. Despite whether you eliminate all energy, radiation, and particles from the universe, it would still not be genuinely void. Our universe is filled with dark matter, quantum fields, and dark energy. Other forces that weave an inevitable artwork, embroidered with something even in its most vacant structure. Regardless of whether we can picture removing everything, these forces, leaving a dead space, the universe would still generate new kinds of energy. This reality is bewildering to specialists, as it suggests that true nothingness might be impossible within our infinite comprehension. Space itself has properties, rules, and constants that prevent it from being totally empty. Imagine creating a region with literally nothing in it, no particles, no radiation, and no energy, except quantum fields and major constants. These would still exist, suggesting that this nothingness has properties. For instance, there's a phenomenon known as zero-point energy, which represents the least possible energy condition of quantum fields. In this state, particles can still momentarily appear and evaporate, making a spooky resonance of movement, even in what should be empty space. This challenges our conception of a genuine void and suggests that yes, even before the Big Bang, there was something that scientists are just beginning to comprehend. One of the most astounding theories in current cosmology is the chance of timeless expansion. If inflation could cause our universe to exist, it's possible it could continue forever. Brian Cox describes an astonishingly vast inflationary multiverse, the location of universes infinitely produced and ongoing, expanding to consider every Big Bang to be a flash lighting another universe, while different areas continue to experience inflation, making countless other universes. This cycle could, in theory, go on for eternity. This idea of vast universes gives birth to the wonderful idea of a fractal universe, in which every new universe could actually produce its very own Big Bang. Each universe is its own entity, an independent domain that is not affected by others, as a result of the rapid growth of space. For researchers, this hypothesis is both exciting and upsetting, as it suggests a multiverse that never ends, with no predetermined beginning or end, our universe being just one bit in a gigantic cosmic structure that never stops growing and constantly makes new universes. And what if the actual problem is that there is no before or after, but rather a timeless pattern of universes forming and deteriorating? When we take into consideration quantum field theory, according to this theory, the universe is not just a collection of space-traveling matter. Rather, it's a complex network of energy fields that fill the universe, connecting to create all that we observe. These fields are like invisible seas, with particles acting as waves or disturbances. Even in the lowest lying energy levels, known as the vacuum state, there are still particles that can appear and disappear in these fields, momentarily acquiring energy before returning it. This phenomenon results in virtual particles, substances that immediately exist before disappearing, leaving only a faint memory of their presence. The idea of virtual particles challenges the idea of a real void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have total nothing? Quantum field theory says no, fields would, even in a vacuum. Research suggests that these ripples in spacetime might carry encoded information from the universe's earliest moments, or even from a time before the Big Bang itself. Gravitational waves, first directly detected in 2015, are generated by massive cosmic collisions, such as merging black holes or neutron stars. However, scientists believe that primordial gravitational waves, waves that originated during the very beginning of the universe, could provide direct evidence of what occurred in the moments before the Big Bang. These ancient vibrations, if detected and interpreted correctly, might be the only surviving signatures of a previous cosmic cycle, a collapsing universe, or even another phase of existence entirely. Detecting such waves is an immense challenge. They are incredibly faint, buried under the cosmic microwave background radiation and the noise of the modern universe. Yet instruments like LIGO and the future space-based LISA Observatory are designed to hunt for these elusive signals. If found, they could radically alter our understanding of cosmic history and reshape our models of the universe. This leads to yet another mind-bending idea, the ekpyrotic model, a theory derived from string theory and brane cosmology. According to this idea, our universe is a three-dimensional brane floating in a higher-dimensional space. Occasionally, this brane collides with another, causing an immense release of energy, which we perceive as the Big Bang. If true, the Big Bang was not the beginning of everything, but rather a recurring event in a much larger dimensional space. The collision between branes could happen periodically, sparking a new universe each time. This would mean that our universe is just one chapter in a never-ending cosmic saga, written across dimensions we can barely imagine. This model also suggests that our universe is cyclic, but driven not by gravitational collapse and rebirth, as in traditional cyclic models, but by interactions in higher dimensional space. In this view, what existed before the Big Bang was simply a different universe or a different state of the brane before the collision occurred. These possibilities challenge not only our understanding of physics but also our philosophical grasp of existence. What does it mean for something to have no beginning? Can we even comprehend a reality where time is not linear, where cause and effect operate differently, or where every universe births countless others? As we move further into the 21st century, the questions surrounding the origin of the universe will remain among the most profound we can ask. While we may never fully uncover what existed before the Big Bang, the pursuit itself pushes the boundaries of human knowledge and creativity. It forces us to confront the limits of our imagination and to reconsider the very fabric of what we call reality. Whether the answer lies in quantum fields, dark energy, multiverse, branes, or cycles of collapse and rebirth, one truth becomes clear. The story of the universe is far grander, stranger, and more awe-inspiring than we ever imagined. Stage waves, if ever found, might reveal new understandings of the universe's earliest times. These waves might be of use as the reminiscences of the past Big Bang. If they can be identified, they might provide proof of the universe's previous states. The potential discovery of early-stage gravitational waves is one of the most exciting possibilities in cosmology today, as it might not only reveal the truth about the Big Bang but also provide a glimpse of the universe's state before our universe was born. This theory offers a tantalizing prospect, detecting waves of gravitation that could act as fingerprints of a pre-Big Bang universe. As we continue to explore what could have existed before the Big Bang, we delve into concepts that push the boundaries of our understanding, challenging even our most fundamental presumptions regarding space, time, and self-existence. Among the most mind-boggling ideas comes from the realm of the study of quantum gravity, which aims to merge quantum mechanics with general relativity. This merger may or may not expose a single theory for everything and could provide insight into what existed prior to the quantum Big Bang. Gravity suggests that space and time are not smooth, continuous entities as we experience them, but instead are discrete, granular structures. According to this theory, the fabric of spacetime itself could have been formed from a structure on the microscopic Planck scale, with tiny quantum changes that shape the universe in ways that we do not yet comprehend. What we perceive from this perspective as the smooth continuum of space and time might have only emerged from these fluctuating quantum fields. Thus, the before the Big Bang could be described by a radically different concept of reality, in which time and space themselves lacked completeness. Another possibility is that the universe is part of a vast cosmic landscape filled with potential universes, each with different physical laws and constants. This theory, known as the string landscape, arises from string theory, which holds that all fundamental particles are actually tiny vibrating strings. In this framework, there are many possible configurations. Each of these strings represents a different set of physical laws. The string landscape could imply that our universe is just one of many, each emerging from its own distinct Big Bang-like event. The landscape also brings forth the notion that different universes might exist with different strengths, different dimensions of gravity, or even different types of matter. In this view, our universe might not be unique, but rather part of a multiverse, a collection of universes, each independently developing. The multiverse theory offers a hypothetical yet intriguing response to the question of what came before the Big Bang, another universe, in a different configuration, potentially leading to infinite cycles of creation and annihilation without a definitive origin. In addition to these, some theoretical models of the cosmos have also considered the role of black holes in determining the character of the universe. A hypothesis gaining attention is the idea that our universe may be the result of a black hole formed in another universe. In this scenario, the black hole's singularity at its center could serve as a gateway to another universe, with the Big Bang being the moment when a similar black hole produced our cosmos. This hypothesis is supported by the fact that, according to general relativity, the singularity at the center of a black hole is a point where the spacetime curve is infinite, creating a region where the known laws of physics fail. The harsh conditions within black holes may result in the development of new universes, which may suggest that what we consider the Big Bang was merely the birth of our universe from the singularity of an ancient black hole. Exploring these concepts requires a deep dive into the very nature of time itself. Some cosmologists speculate that time, as we understand it, may have had no meaning prior to the Big Bang. Assuming that the Big Bang was the beginning, then there may have been no before in any standard sense. This point of view suggests that time itself might have emerged from a quantum fluctuation, or from an initial state in which the usual distinctions between past, present, and future did not apply. This could lead us to reconsider the idea of causality, which is predicated on the idea that events take place in a straight line. If time did not exist in the way we experience it, then the issue of what came before the Big Bang becomes absurd, because there wouldn't be any temporal framework to support it. Complicating the picture are theories of cyclic time. As mentioned previously, cyclic cosmology posits that the universe undergoes endless cycles of birth, evolution, and eventual collapse. In this model, the Big Bang could represent merely the most recent swing in an eternal series of universe cycles. These cycles might not be identical but could change in various directions, each with unique physical properties. In this theory's view, the universe would be an ongoing process without true beginning or end, rendering the question of what arose prior to the Big Bang, in the conventional sense, meaningless. The notion that time might be cyclical suggests that every Big Bang could be followed by a contraction and another big crunch, with the universe reinitiating itself in an endless loop. A different avenue of inquiry into the potential of the cosmos is its nature as a primordial soup of particles and fields that existed prior to the establishment of galaxies and stars. This idea suggests that before the universe began its rapid expansion, It was filled with a dense and hot mixture of elementary particles, including quarks, leptons, and bosons, all in a state of extreme energy. These particles would have been interacting at extremely high densities and temperatures, laying the groundwork for the formation of matter and energy. Some versions of this theory suggest that this primordial soup existed in a quantum foam, where particles kept appearing and vanishing due to the uncertainty principle of quantum mechanics. The soup's properties have the potential to offer insights into the universe's earliest moments, and by extension, what preceded the Big Bang itself. As we stand on the brink of these profound questions, science is gradually transforming the unknowable into a landscape of possibilities. Tools like the James Webb Space Telescope, gravitational wave detectors like LIGO and Virgo, and next-generation quantum experiments are slowly peeling back the layers of cosmic history, offering glimpses, however faint, of epochs we once believed lost to time. Each discovery brings with it not just answers, but deeper, more nuanced questions. Could the faint background radiation we observe be more than an echo of the Big Bang, perhaps a remnant of cycles before it? Might black holes not be ends, but beginnings in disguise? Is the universe's inflationary burst after the Big Bang a signature of something that came before, like the snapback of a cosmic slingshot? Our models evolve, sometimes confirming ancient philosophical musings, other times shattering our most cherished beliefs. And in this dance between knowledge and mystery, we are reminded of the limitations of human perception. The universe may not only be stranger than we imagine, it may be stranger than we can imagine. Yet, this has never deterred us. From ancient stargazers to modern physicists, the human spirit has always sought meaning in the stars. What came before the Big Bang may ultimately be unreachable in a direct sense, but by pushing the boundaries of mathematics, imagination, and observation, we might one day grasp the framework that holds such a question. Whether time is linear or cyclical, whether space is infinite or looped, whether our universe is unique or one of an eternal multitude, the journey to find out may be more important than the answer itself. In striving to understand what preceded the universe, we are, in a way, striving to understand ourselves, our place, our origins, and the nature of reality itself. The universe does not give up its secrets easily. But it does whisper, and if we listen closely, we may one day hear the echoes of eternity.